Let's do it. Hello, everyone.
Hey.
Hello.
All right, it's now Wednesday, December 8th. And looks like we're going to be covering questions for December 7th, Tuesday, and today, Wednesday, December 8th. So how are you guys doing before we get into it all?
Managing so far. They're getting harder.
Yeah, a little more challenging.
But yeah, they've been fun so far.
Yeah, I'm still trying to, I have an answer for, was it day 6, day 5 that I haven't done yet, but
I think day 6. Day 6.
But I'm waiting to try to optimize my code to see if I can get a better performance out of it. I don't like the way it's running now. So that's the only one I'm missing so far. But I noticed, I think Scott, you're all caught up. I think Farouk too. Farouk, you're missing.
I have part 2 of day 5 missing.
And then Alexei, you are down a day.
Yeah, day 5.
Okay.
I couldn't make it, and part 2, day 7 or so.
Okay.
So.
Yeah, so we're starting to see a little bit of delay in these 3 of ours.
Yeah.
And like I said, it piles up, but you can skip days, so keep that in mind. So don't feel like you have to get this done before you continue. You can always come back to it later. Without further ado, let's get into yesterday's. So let me share my screen and we'll get into it. See, this one did that. And so yesterday is day 7.
Right.
The treachery of whales. So who wants to read this one? Wow, so many volunteers. I'll read this one.
Thank you. I'll read the next one.
A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny little submarine. It's too deep for them otherwise. I don't know about that. I've seen crabs. Anyways, they zoom in little submarines to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming.
Ooh.
Ooh, yeah. Crab submarines all need to be aligned before they have enough power to blast a large hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. One major catch. Crab submarines can only move horizontally.
Naturally.
How did they get that deep? Nobody knows. You quickly make a list of the horizontal position of each crab, your puzzle input. Crab submarines have limited fuel. Where did they get this? Only moving horizontally. So you need to be able to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. Why don't they just blast the whale? I guess it's weird, right? That's kind of a mean thing to do, but
that's not something Santa Claus would do.
For example, consider the following horizontal positions: 16, 1, 2, 0, 4, 2, 7, 1, 2, 14. So this means that there's a crab with horizontal position 16, a crab with a horizontal position 1, and so on. Each change of 1 step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them on, but the one that costs the least amount of fuel is the horizontal position 2 for the sample puzzle. And they're saying that if you use 2 as that single common point, then to move from 16 to 2 is 14 fuel, right?
Yeah, you're moving 14 places, so okay.
Places, right? Moving from 1 to 2 is 1 fuel. From 2 to 2 is 0 fuel, and so on, right? Depending on how far each crab is from this common meeting point. If you add them all up, This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning the position at 1, for example, which costs 41 fuel in total, or position 3, which costs in total 39 fuel, or even position 10, for example, which would cost 71 fuel. Determine the horizontal position that the crabs can align to using the least fuel possible with your puzzle input. And how much fuel must they spend to align to that position? So how much fuel must all of them spend in order to align to that single common position that you think will be the cheapest for them? And so that is the question for day 7, at least part 1 of the questions of day 7.
Okay, that doesn't sound too difficult for part 1 at least.
Yeah, I think pretty straightforward.
Yeah, so you need to test pretty much all of the different possible horizontal positions and see what the total fuel usage is going to be for each position.
Right.
And find the position with the lowest fuel usage. Okay.
And I think we've all done this one, right?
First part,
Yeah.
And so, it's at least, even without discussing it, it was something that we can understand. So, there's nothing really like tricky or hidden about it. What you see is what you see. Okay, cool.
But there is one tricky point here too. I think for the part 2, in that line, it says you could choose any horizontal position to align them all on. You have to be careful about that one. That line.
Sure. Yeah.
Can be any horizontal position.
Right. Yeah. Looking at the first thing, you might say, oh, you should probably choose the mode because, the most common positions means that the least amount of people need to move.
Yeah, it's going to be somewhere in the middle.
But then, well, that's the mean, right? The mean would be or the median.
Yeah, but it's not going to be exactly that.
Yeah, it's not going to be the mean. It's not going to be the median. It's not going to be the mode. It's going to be something, probably something else. Maybe not. But, it's something to try. But I think, I don't know. I don't want to give away too much, obviously, because I'm sure someone's like, oh, I was going to try the mode. because in the sample answer, it is the mode, right? There's the most 2s in the list. So 2 would be kind of a natural thing you would gravitate to. At least number has to move, but I think that might, might have just been coincidental. Anyway, cool. All good?
Yeah, good for me.
All right. So that's day 7. The treachery of whales. I think whales are getting a bad rap. Whales are kindly creatures.
Yeah, they're not going to attack.
Unless you
All
go.
right, looks like an old digital clock.
All right, so 8, 7 segment search.
All right, I said I'd read this one. So here we go. 7 segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Oh no, we're stuck. But sensors indicate another exit to this cave at a much greater depth. So you have no choice but to press on.
The jerk whale.
I know, now we're trapped in a cave and we got to go deeper and deeper. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of 7 segments named A through G. All right, and in the example here, it looks like the numbers on an old digital alarm clock or any kind of digital clock that has a segmented display like this. So we have 7 different segments, A, B, C, D, E, F, and G. And it shows you all of the different numbers here. So if we look at number 0 needs segments A, B, C, E, F, and G. It doesn't have the middle line, so it doesn't have segment D. Whereas number 1 only has 2 segments lit up. It has C and F. And we can look at all of the other numbers too, and each number has a unique combination of segments lit up. All right, let's continue on reading. So to render a 1, only segments C and F would be turned on. The rest would be off. To render a 7, only segments A, C, and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers producing output on signal wires A through G, but those wires are connected to segments randomly. Oh, the wires are all mixed up, so our segments aren't in the right order. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1. So it must mean segments C and F are meant to be on. With just that information, you still can't tell which wire, B or G, goes to which segment, C or F. For that, you'll need to collect more information. Oh, wow. So we're going to have to figure out which segments match to which letters in our inputs. Okay, this sounds a little fun. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, your puzzle input. Using the signal patterns, you should be able to work out which patterns correspond to which digit. For example, here is what you might see in a single entry in your notes. A, C, E, D, G, F, B, C, D, F, P, E, and so on. And if you notice on the top line, we have 10 groups of letters. So if we count all those, we have 10 groups of letters on the top line. And on the second line, we have 4 groups of letters. So that's what it meant. It said they wrote down all 10 unique signal patterns. That's on the top line here. And then they wrote down a single 4-digit output value. That's on the second line here. The entry is wrapped here to 2 lines, so it fits. In your notes, it will all be on a single line. Okay, so in your input, it's going to be a single line. Only this sample is special. Let's continue. Each entry consists of 10 unique signal patterns. What do we call this? A pipe delimiter?
Sure.
And finally, the 4-digit output value. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB in the above example means that to render a 7, signal lines D, A, and B are on. Because 4 is the only digit that uses 4 segments, E, A, F, B, means that to render a 4, signal lines E, A, F, and B are on. Using this information, you should be able to work out which combinations of signal wires corresponds to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value, CDFEB, FCADB, CDFEB, CDBAF, use 5 segments and are more difficult to deduce. For now, focus on the easy digits. Consider this larger example. And now we have a second sample input. This one's a lot larger. It has multiple of those lines. So on the first line, we see 10 groups of letters, and then 4 under that, and so on. We have a lot of different samples here to look through. So let's keep scrolling, please. All right, and if we look at that sample input here, we'll see some of the letters or some of the groups of letters are in bold. Those are the letters that must be the digits 1, 4, 7, and 8. Those are the ones that have a unique number of segments. Like we saw, the number 1 only has 2 segments, 7 only has 3 segments, the number 4 only has 4 segments, and the number 8 uses all 7 segments. So those ones are unique. Well, because the digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after pipe on each line, in the above example, there are 26 instances of digits that use a unique number of segments, highlighted above. In the output values, how many times do digits 1, 4, 7, or 8 appear? Wow, this is a long question with a lot to it. Luckily, it seems like part one is much simpler than I expected it to be.
Okay.
Part one, because they tell you, you only have to find the total number
Instances.
of 1, 4, 7, and 8. So you just got to count the groups of letters that have a unique number.
Right.
So that's not as difficult, but I think we can pretty much guess what part 2 is going to be already. I'm guessing part 2 is going to be everything. You have to figure out what each combination is, what each number is in each little display. And you'll probably have to do something with all the output values. So I think part 1 here is a lot easier than part 2.
Could be, probably.
Are you guys okay? That's a lot of reading. Did you guys understand enough?
What really not really clear for me
Mhm.
is, so there is a 10 first, then the delimiter, and then the other 4 all the time.
Correct.
Every single row. We need to compare the 4-1 with the 10th. Like if they match, it means is either 1, 4, 7, 8.
No, I think what they're saying is that you have more clues. Really, you're only going to count the things that are in the 4-digit section after the pipe. Those are the ones you're actually going to count.
Yeah.
But they gave you all 14 as kind of a clue as to what those 4 might mean. Because remember, within a display, they're all going to be wired the same. All the C's are the same, all the B's are the same, all the A's are the same. But which segment the A, B, and C is going to be different for every line.
Yeah. Can we see a sample input? Or can we see someone's real input?
Yeah, you can see mine if you. I can show you guys mine if you want.
Okay. I think it would help to see what the real input is going to look like.
Okay, I share my screen then.
Okay.
Because if we take the first one, G, C, D, E,
Mhm.
it's not a real digit.
So I think this is. Can you guys see my VS Code?
Yep.
Okay. Yeah.
This
So
is
that's
sample
your,
input,
yeah.
Mhm.
and
Good.
this is the real input.
Okay. So it's like 180 something lines.
I think 200. Yeah.
Yeah. So for part 1 of this question, you can completely ignore everything before the pipe symbol
Yeah.
on each line. You don't even need to look at the things before the pipe for part 1.
Yeah.
But you'll still have to do some work to format your data and
And
do everything.
for what you might be coming in part 2, like you said, like there is a process or a logic to the way that the line was constructed.
Yeah.
Yeah. So basically, I think there's 10 is the possible outcome of 10 digits. So we have 1 here, we have 2 somewhere, and 3, 4 with only 4 characters. Here is 4. We have 5 and 6 and 7 is probably with 8 cents.
7's CGB.
Yeah.
Yeah. So
Yeah, here 7 is 3 segments. So based on that, I think we have to find all the digits and then figure out what, do something with the outputs probably.
Yeah, well, you only need to count the outputs.
Yeah.
And it does say that, 1, 4, 7, and 8, they're unique.
yeah.
And you really only need to count the uniques. So, what Scott was saying is that for part 1, you don't really even have to count all 10 of them because they're unique numbers. You're going to find all the pairs that have only 3, all the pairs that have only 2, all the pairs that have only,
Maybe
all 7.
2, 3, 4, and 7.
3, 4, and 7. So you just need to find in the second part all the numbers that have 2, 3, 4, and 7 in length.
Yeah.
So there's the answer for you.
Still got to code it though.
Still gotta code it. And then be prepared to be a little bit more complex in part 2, which they'll probably ask you to do something crazy like multiply all the numbers regardless of what number they are or something like that. I don't know.
This is
I guess.
literally a story to confuse everybody.
Yeah, it could have made it a lot easier if they just skipped it all out and just told you that one line,
Yeah,
4, 7, and 8 are unique, count them.
yeah.
And then just eliminate the first part of all the puzzle input.
Because I was trying to check like the first line GCBE and trying to like that's not the numbers. Like why do I need to count these guys?
GCBE has 4, so it's probably going to be the number what?
4.
4, right? Because 4 has 4 segments lit up. So you know GCBE will be 4, but you don't know what G lights up. You don't know what C lights up. You don't know what E lights up, so on. So, but that's going to help you get the clues to figure out eventually, I'm thinking, because you're going to have to know how to produce a difference between the number 2 and the number 5, which both have 5 segments, right?
Yes.
Yeah.
Or 6 or 9.
6
which
or
has
9, which
6
have 6
segments.
segments, right?
Yeah.
6, 9, and so using some deduction about how certain segments were lit, you're gonna be able to figure out which letters go to which segment on the 7-segment display, so that you can now know which 6 segments, which of the 6 segments produces which of the numbers, whether a 6 or a 9.
I think part 2 for this question is probably going to be one that you'll want a notepad and a pencil to probably draw it out, at least for 1 or 2 times, so that you can get the logic going in your head, and then you'll be able to put that into code. But I think it'd be good to start with a notepad.
Well, it sounds like Scott, you already did part 1.
Part 1 wasn't so bad. Yeah.
So I'm just guessing about what part 1 is, or part 2 would be, because I haven't actually done part 1, but there's probably a reason why they gave us this entire story and like the logic and everything else. But yeah, it is special in the sense that they're really front loading all the information versus some of the other puzzles where they just only gave you the information that you need for that specific puzzle.
Yeah. Well, there's often hints this year for part 2, like in the bingo one, where where the vents that were spewing clouds, and it said, for now, ignore the diagonals.
Right.
That was a giant clue that part 2 was going to include the diagonals. Like if you look at today's input, knowing that part 1, you can ignore the majority of the input, you're probably not going to be able to ignore it for part 2.
Yeah. Well, it doesn't explicitly say you can ignore it, right? It just says you need to count the number, these numbers, and these numbers actually happen to be only the ones that are actually currently predictable because they're unique.
Yeah. Doing advent of code for the 2nd year now, pretty much nothing in the input values is extraneous information. It's all necessary. So I'm pretty confident we're going to be using it.
That would be nice, or not nice, but that would be, an extra challenge, is to just start introducing noise into your input.
Maybe closer to day 20.
Actually, there have been, I take that back, there have been days where there have been noise in the input. But anyway, any other questions on day 8? No. All right.
Have to get started.
Yeah, you said things are ramping up little by little. So we're now almost a third of the way through. Day 8.
Yeah, once you're done.
But stick with it, and let's see where it goes. So without further ado, let's move on to answers now for, I believe, day 3.
Yeah.
Okay. So let's do a quick review on the question itself for day 3. I will reshare my screen. Oh, it might make sense. Well, I'll share the part one, and then someone, or I guess I can do it too, but someone who's actually done part A will obviously be able to see the second part of the question. But part A, just to summarize really quickly, it looks like we're trying to find two different rates, the gamma rate and the epsilon rate, and it's based on these numbers, these seemingly binary numbers that are being spit out from this sensor, I guess, that you've sent forth or something like that, right? The diagnostic report. And depending on the numbers that come back, it looks like we're processing this the way that, well, I'm not sure if it was described or not, but the way that I ended up processing is in a columnar format, because we have to find out which is the most common in the first column and then which is the most common in the second column, and so on and so forth. The number that is the most common, 1 or 0, ends up being the gamma rate, and the one that is least common ends up being the epsilon rate, right? And then each of those, depending on, like, for example, the first column, the most common, if it's a 1 in their sample, and the second column, the most common is a 0. The third column, the most common was a 1 in our sample. So it says right there that if we took all of those, where 1 was the most common in the first column, 0 was the most common in the second column, 1 was the most common in the third column, and then 1, and then 0. If you take that and you translate that as a binary number, you get 22 in decimal, from binary to decimal. And so hopefully your language, and most languages do, have some way of translating this binary number into decimal so that you don't have to do it manually. But you can do it manually with powers of 2. So you won't be completely out of luck, but most languages, I think, do come with some sort of tool to do that conversion for you. The epsilon rate also is basically pretty much the opposite of that one. And that one ends up being a 9 in decimal. And then if you multiply the actual decimal numbers, 22 and 9, you produce the answer, which is 198. And so we're going to do the same thing, but with the input that we have. And the input that we have, like, for example, if I were to show mine, let me switch to my other screen. I believe my input ended up looking like, I guess, much larger, more columns. I think so. I had, looks like, I'm just going to grab the scroll bar because there's a lot of them. Looks like there's 1,000. Oh, wow. Okay. So there's 1,000 rows, and how many columns are we looking at here? We're looking at 12 columns.
12.
Yeah. So it's quite a few. But, you know, depending on your algorithm, how many columns and how many rows there are, it's not really going to make too big of a significance, because your program will just chug away without complaining, hopefully. So I'll start out doing my solution, since I'm already sharing my screen. So we're going to start with Rust this time.
Yeah.
All right.
I'm not going to go too much into the, try to stay away from the specifics of the language. If you guys have questions, obviously I'll be more than happy to answer it as much as I can, because even I'm a beginner with this language, and I'm sure there's going to be some Rust programmers out there saying, like, this is atrocious. Yeah, like you call yourself a Rust programmer. Let me make it clear, I do not call myself a Rust programmer. This is how a programmer from another language tries to talk Rust. But anyways, this is how I got my way around it. So the first thing looks like what I do is let me like refresh my memory here really quick. Looks like I have my input. I'm going to go through a reducer to get a vector. Oh, I start by initializing a vector that has the same number of columns as the input. So for example, our input has a 12-column input. I start by creating a vector of 12 elements and just set them all to 0. And then as I go through each line, if this line has a 1, then I increment that line by 1. So essentially what I end up after the reducer is done, I end up with a number of 1s for each column, right? And so for the first column could have like, there's 1,000. So the first column might have like 325, and the second column might have 215. The third column might have 2, and the third column might have 125. Third column, or the last column might have 999, whatever. But each column tells me how many 1s were in that column. And then I have what's called the majority, which, it's just basically the number of input, 1,000 lines divided by 2. Because my logic is, as long as that number is higher than the minimum for the majority, then I know that 1 is the most. So for example, if it's 600 ones in the first column, that beats the majority number, the minimum for the majority of 500. So I know that that 1 was the most common for that one. So that was the kind of my logic, my approach for this one. So in the gammas array for line 36 to 38, I count going through each one of those. If X is more or less than the majority, if X is the majority because they're counting number of ones, then I make that a 1. Otherwise, I assume 0 was the majority and make that column 0. And so there I'm making that 1, 0, 1, 1, whatever column just to signify which was the most common in that column. After that, I think is just housekeeping. I turned that gammas array into a string, and I needed a string so that I can use this utility function to turn that string into a decimal integer. So that binary string into a decimal integer. I have this function that comes from the language, but it needs a string in order to work. So I convert it into a string so I can use that function. And then I end up with an integer value. And then the epsilon, I do a very similar thing, except instead of counting, I just look over my last answer and I just invert all the ones to zeros, all the zeros to ones. I could have also done an XOR, and a bitwise XOR, but I have my gammas array as an array of strings, as an array of characters actually. So then I would have to convert it into bytes or bits, and then I would have to convert the bits. So I said, forget that. It's already a string. It's easy to just parse in a string. So if it's a 1, then this other one is a 0, and so on. So now epsilon string should be the complete opposite of the gammas array, right? So everywhere there's a 1, there's a 0 now, and everywhere there's a 0, there's a 1 now. And then I do the same thing. It's already a string. I can use this convenience function, turn them into an integer, and then I just multiply the 2. That was my approach.
It's still difficult to read for me.
Yeah, reading is another thing because Rust is not really, there's a lot of, at least the way I've been coding it, maybe, there is some Rust programmer will chime in and say, there's a much more succinct way of writing what you're writing, but this is what I've found so far. Yeah. But you'll find that my code is going to be littered with collects, unwraps, which is probably not idiomatic Rust, because I know that unwrap basically assumes that everything's going to be okay. Otherwise, I can break it out into an option which has a sum or a none, but then it just makes the code that much longer to read. And it's not production code, it's just to solve the puzzle. So I just assume if it's not going to work, panic crashing is okay. I'll just go back and fix it. But that's the context in which we're writing this curve for so far. And then there's just a lot of, I guess, housekeeping, like I said, just inversions and type annotations and stuff like that. And that makes it not easy to read unless you're familiar with it.
Well, your explanation made it seem very simple. So thank you for the good explanation.
Yeah. So my approach was just taking it, counting the ones, getting the the minimum to make the majority, and then that tells me what order the ones and zeros go in. And then for the gammas, I just took that string and just inverted everything and then multiplied the 2 together. But I have this great convenience function to turn that string into an actual decimal. If not, I could have gone, I guess, to each integer and then multiplied by the corresponding power of 2, but I didn't have to. Anyway, questions?
All right.
All right, who wants to go next?
Okay, I'll go next.
Okay, thank you.
Python.
Yeah. Okay, can you guys see my screen?
Yep. Could you just, for my sake, minimize or shrink the terminal on the bottom so we can see more of your code? Thank you. Yeah, that's good.
Like this?
Yeah.
Sure. So this is a part 1 of day 3. Cool. What I'm doing is first I'm getting the input. let's say here is the input, I'm reading it and splitting it by space, by a new line. Yeah, so it's there in a list with comma, separated by comma. So I have variables, rates, and I'm looping through, I'm simply basically looping through the input and counting the ones and zeros in each row. And based on that, I'm adding certain characters to gamma or epsilon rate. Not like, I like what you did, Alex. You just have keeping track of one and just with Zor operator, you are finding the opposite of the gamma rate at the end, right? But in me, I'm keeping track of both and returning them by multiplying after converting them to decimals in the end. So here, the first loop is for the length of the input. For example, here it's 12 times. On the sample input, it's 5 times. I loop through it 5 times for sample input. And second one is for the length of the input. So for here, we go for 1,000 times. So every time we count, we check which character is in that certain index. If that character is 0, we increment zeros, otherwise we increment ones. And if 0 count is larger than 1, we make those tracks. Otherwise, we make those tracks. Yeah.
Okay.
And at the end, I'm converting them to decimal with this Python
Yep.
built-in method.
Function there.
Returning their multiplication. Yeah. That's it. Any questions? Oh, I think this was not necessary. Yeah.
Much cleaner to read than my code.
Yeah, it's Python is like English, I think. Cleaner to read than most languages.
A lot more flexibility. You don't have to tell it like, oh, this is going to be this particular type, and then in order for this type to be turned into integers, you have to do this, and in order to do binary, you have to turn into a string, and then you can do that. It's definitely cleaner looking.
I think only thing I have difficulty sometimes is this spacing. Yeah, it's important in Python where they should be.
Right.
The rest is fine. Yeah.
Cool.
Any questions?
That's clear.
Looks good.
So you're going by column, right? So the first column, you're going through all the rows. And then you're getting the second column, you're going again through all the rows. And the third column through all the rows. The fourth column through all the rows.
Yeah.
That's your looping structure. Okay.
Yes.
Cool.
All right.
Well done. Should I go next?
Sure.
Right.
All right. I am not proud of this one. I'm gonna just say that right away. My code is messy, and I thought of one thing and just went with it until it worked, but it's not beautiful. We're
not publishing anything, so
if I had a lot of free time, I'd go back and make it look a little prettier, make it cleaned up, but it works, so I'm gonna move on.
I think every day is going to be like this now, starting day 4, day 5, so it's not we start tomorrow.
They're getting longer, getting more harder. This one was actually fun.
Tomorrow.
Day 1 and 2 were honestly too easy, so it was nice to have a little bit more of a challenge on day 3. This one took me a while. I had several distractions in my family too, so I kept getting pulled away and having to come back in the middle of my code and figure out what I had just written. So I don't like it, but I'll try to explain what I thought and how I did it. So first, I got all of my input. I got it all into an array of subarrays, which might do it differently if I had to do it again. So each row of my input will be in its own little array with each element in there split up into each element in the array, like this.
So an array of strings.
Yes, array of strings. But then I didn't like the way that was going to work. I didn't want to have to use loops inside of loops inside of loops in order to go through that data. So I decided the first thing I wanted to do was just to rotate my array.
Okay.
So the first thing I did, I just created this function to take each element in my array and rotate it to create a new array with all of the columns now as rows.
Right.
So that made the next part quite simple, actually. It looks a lot like Alex and Farouk's code, where, well, more like Farouk's code, where I'm just checking through all of the values. And then I created my gamma and epsilon variables here. And I'm gonna keep my length of my array constant because it's not gonna change. And now for, what did I do here? Let me take a look. So I created a just temporary variable here to capture all of this. So I'm reducing, what was I doing here? A minus B. Okay, so I was summing up all of the values in each row. So I summed up the values in each row, similar to how Alex did it. And then I compared that. I divided that by 2. And if it was greater than the median value, then I would do this. So no, sorry. Let me check. I'm trying to, my mouth is faster than my brain right here.
If it's a minority, then you added it to the epsilon. Otherwise,
That's right. So I had to take care of gamma and epsilon separately. I could have also only counted gamma and then calculated epsilon from that later, but it was easy enough to just add 2 lines in here to take care of them both at the same time.
Yeah.
So yeah, so I got my gamma and epsilon strings. I return those. And in here, I use the parseInt function that JavaScript has using a base 2.
Right.
So that'll calculate the decimal number from the binary.
Yeah.
And okay, so now I just had to put my functions together. I put my input into my rotate function and put the result of that into my getValues function. And that gave me my final answer.
Cool. I like how you used the full advantage of UTF-8. You used the Greek letters as variable numbers, as variable names.
I was actually testing a lot with what is possible to use as a variable name.
Yeah.
I was really disappointed to find out that you can't use emojis as variable names.
Oh, really?
Yeah, I wanted to just put like smiley faces and rocket ships everywhere and diamonds.
Create your own emoji code, huh?
But yeah, you know, I liked just using the Greek letters instead of typing out gamma, epsilon. I don't know. To me, this was really descriptive, although it made it more difficult because I had to copy and paste every time I wanted to reuse it.
Yeah, I was about to say, do you even know what on your keyboard?
Well, that's one of the things about Advent of Code is I like to try to have fun while I'm doing the puzzles. I know it's not production code, so I'm just trying to have fun with it.
Yeah.
Play around with the language, learn some new things while I'm at it.
Okay.
Yeah.
So your approach was that you took all the columns and processed them into rows because rows are easy to work with as a for loop, right? So you pre-process your entire input into an array of the column values.
That's right.
You ended up after the first part with an array of 12 elements, and each element was all the column numbers for that particular column. And then you add those together to do your counting, to do your majority test. Cool.
All right, Alexi.
I'm proud of your code, Alexi.
Scott or mine?
Are you proud of your code?
You.
Fine.
All right.
You don't need
All
the
right,
disclaimer at the beginning.
I'm not proud of my part 2 though.
Notice I'm already day 13. By
Oh, look at this guy.
Whoa.
You know somebody.
Are you psychic, man?
Who'd
you bribe to get those questions?
I'm okay. Yeah, maybe Zoom once. That's good.
Okay. So pretty much first just initializing a variable, just gamma, epsilon, and a counter for me. And then I just did a for loop in another for loop. And then I did the same as Farouk, actually. I did by column. So I'm just counting if I face a 0, then I just plus to the counter. And then when I arrive at the last one of the loop, then I'm checking if there is more 0 than the median of the puzzle. If there is more, then I believe that's gamma and then epsilon plus 1. Otherwise, it's gamma 1 and epsilon 0. And then when it's done, just made it like in 2 lines just to look cleaner. Same convert binary to decimal with the parsing. And then it's just 2, it gives the decimal. And then the last one is just multiplying. Basic. So yeah, I went with colon. I think it was for me easier. Just the trick was to check it, put J before instead of I. Otherwise, it would be a line.
Right.
And then you wouldn't get the right answer. Okay, that's it. Pretty straightforward, this one. It took me, I think, a little bit longer for the second one than the one.
For your if condition block between lines 18 and 26, could you move that underneath the for loop that it's nested inside of?
You mean if I do
And get rid of that first condition then? So I think you could,
this and put it there?
yeah, I think you just move it right at the end of the for loop, but inside of the initial for loop.
Yeah. So then
And then you can get rid of lines 19 and 27 right there.
Sorry, say it again.
So comment on 19 and 27.
Yeah, just remove line 19 and then remove the bracket on line 27.
Line,
Remove
line.
everything. Just,
Yeah,
yeah,
line,
just
line.
that line and that one. Yeah, I think that would be essentially the same thing because now it's going to run when that inner for
After,
loop
yeah.
is finished.
Yeah. I think we'll do exactly the same. I don't think.
You can test it. See if you get the
Yeah,
same.
make sure I didn't break everything for you.
Yeah, that'd be the quickest way. But it looks like it would be the same.
Was that your answer?
Right answer. Calendar. It's day 3.
You can check it on your edit
Yeah.
of code.
I'm on it, and it's the same. It's the same result.
All right.
Yeah, I think that way's a little bit, this way is a little bit cleaner because you don't have that condition in every loop of the inner for loop.
Yeah, that's true.
All right, looks good. Pretty much the exact same as Farouk's.
Yeah. Now it's
Did you
now
guys work
it's your
together? Are you working
you
together?
are
to be-
outside the second for loop. It's same now.
I was thinking actually at
Yeah.
first not doing like the 2 lines, just like let's say implement gamma 0, and then at the end, like when I got my gamma, just loop through again the gamma, just the string, just like do the opposite. But I was like, yeah, I think it's pretty much the same. So I don't know in terms of speed.
Yeah, looks good.
Yeah.
Most of our code is the same too. All right,
Okay.
conditional.
Exciting
then-
part now.
Part 2.
Yeah.
This one.
I told
So-
you.
We should probably let's read the question for part 2.
I need to share different screens though. I need to stop sharing, I guess, to share different.
You can share and read if you'd like.
You guys see it, right?
Yep.
Okay. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in a diagnostic report. Finding them in the tricky part. Both values are located using a similar process that involves filtering out value until only one remains. Before searching for either rating value, start with the full list of binary numbers from the diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching for. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. The bit criteria depend on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only number with that bit in the position. If 0 and 1 are equally common, keep value with 1 in the position being considered. To find CO2 scrubber rating, determine the least common value, 0 or 1, in the current bit position, and keep only number with that bit in the position. If 0 and 1 are equally common, keep value with 0 in the position being considered. So actually the opposite, this one or this one. For example, to determine the oxygen generator rating, value using the same example diagnostic report from above. Start with all 12 numbers and consider only the first bit of each number. There are more 1 bit, 7, and 0 bit, which is 5. Talking about those, which is here. More 7 and 5. Okay, so keep the only 5 number with a 0 in the first position, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, and on and on. Then consider the second bit of the 5 remaining numbers. There are fewer 1 bits, 2, than 0 bit, which is 3. So keep only the 2 number with a 1 and 1 in the second position, 0, 1, 1, 1, 1, and 0, 1, 0, 1, 0. In the third position, there are an equal number of 0 bits and 1 bits, 1 each. So to find the CO2 scrubber rating, keep the number with a 0 in that position, 0, 1, 0, 1, 0. As there is only 1 number left, stop. The CO2 scrubber rating is 0, 1, 0, 1, 0, or 10 in decimal. Finally, to find the life support rating, multiply the oxygen generator rating, which is 23, by the CO2 scrubber rating, which is 10, to get the result of 230. Use the binary number in your diagnostic report to calculate the oxygen generator rating and CO2 scrubber rating. Then multiply them together. What is the life support rating of the submarine? Be sure to represent the answer in decimal, not binary. Okay.
All right, so this is a lot more difficult than part 1. This time we're still starting out the exact same, right? You have to find which number, 0 or 1, is the most common. But then for the 2 values that we're getting, the oxygen rating and the CO2 rating, we're going to eliminate all of the other rows. Okay. So your data is just going to keep getting smaller and smaller and smaller until you narrow down on that one row that's going to be that value you're looking for. Okay, let's see it.
All right. So what did I do? And I wrote some comment.
Always good.
Yeah. Okay, so first I initialize way more variable than before. Okay. Oh yeah, I think I duplicated a lot for the oxygen array, CO2 array. Just start with the puzzle at first. And then there is a counter for both array. And okay, there is 0. We start the loop. Oh, okay. The first time we are gonna pass through the puzzle. Look through each chart of the first element of the array is every letter of the same length.
Yeah, so you got 12 columns, so you're going to go through the first for loop 12 times.
Right. If I equals 0, so the very first time we pass here, otherwise we're gonna pass there. Okay. So okay, first time we pass into the puzzle, we do the same. We count the 0, and then at the end of this for loop, the last iteration, then we checked exactly the same as earlier. I put either 0 or 1 if according to how many 0 there is in this column. Then I push it. No, I didn't push it. Okay, AoC remove. Searching for the 0. Then, okay, because I wanted to remove the data, so I created a different array. So,
So it looks like you're counting the zeros.
Yeah,
Like
I
only the
always do.
zeros for every column.
Yeah.
Right. And then if you find a 0, then you mark it. Hey, I found a 0 by adding 1 to the AoC0 counter. Or if you find, but for the CO2 scrubber, you're counting at the same time. Then you have, but you're also counting the CO2 0 counter with the very similar criteria. What is the AoC array and the CO2 array? Are they the same?
CO2, which one?
CO2 array and the AoC array that we see in the top of the for loop on 36 and 44. Where were those created? The AoC are and
Totally on the top. I initiated them at first with the first
okay, just
puzzle.
the puzzles.
Yeah.
Okay.
And then okay, that's the first one. I totally forgot.
No, it's the same thing. The outer loop that you have is going through each column, right? Because you're going once through each column. And then these inner for loops in the if and the else, you're going through every row in all the answers. So basically you're going through the entire list of 1,000 twice. Once for your first for loop in 3600 and again in the second for loop in 44. So you're going to the first column and then you're going through once so that you can get the AoC0 counter, and then you're going through again from the beginning again, another 1,000 to get through the CO2 0 counter. And then at the end of it, if it's the last of any one of those, you're adding up, or you're basically determining, is this a 1 or a 0, based on what was returned. What is, I guess, the whether or not it's greater, whatever it's greater than. So the 0 counter and the AoC counter, then if you scroll up, oops, down, sorry. The only thing that's different is in line 40, you have 1 is greater than, right? So if there's no zeros, then the length, then it becomes a 0. But then in 47, it's if it's less than or equal to, then it's a 0, right?
Right.
So it's the opposite.
Which I think I could have put this one here.
I think with the same with the last one, you could have moved the if on the outside.
Yeah.
And then just counted the other as the opposite, right? You didn't have to count both of them twice.
Yeah.
But anyway, you got it to work,
Maybe
counting both of them. So you count both of them, you figure out which one is the most common and the least common at the same time for each one of the columns. So now you have something called an O2 remove, which has all the most common that are the most common zeros. How many have zeros as the most common? And then you have another one called CO2 remove, which has the most common as 1 as the most common, right?
Which is the opposite, yeah. Then filters are but seriously, I can't think of, I don't remember.
Okay.
Just like 5 days ago, but still can't remember.
Okay, so if you have at least 1 left, right?
Yes, if there is 1 left, then that's the 1. So,
yeah, so if there's not 1 left, then you're going to run through a filter.
Yeah.
The filter is you're going to be checking, looks like you're going to be checking the value at whatever it is, the current column that you're looking at. So that first column, if this first column's value is the same as oxy remove, which is a 0 if the 0 is most common. If it's the same, then we return the value, right? Then we return the 0.
Just try to run to see what I got.
And then you do the same thing with the CO2 array. You're going to filter on that one as long as the character, again, at that first column is the same as the CO2 remove, which is should be the opposite of the other one, right? Because we use that those two either greater than or less than or equal to. It should be the complete opposite. So if the first oxy R is zeros, then we return a 0. The second one, if the CO2 array was 1, then we return the 1. But what if it doesn't? Oh, but you're filtering. So it just basically counts. Or it becomes the final oxy array and the CO2 array are an array, but smaller values, because now this oxy array only contains zeros and the CO2 array only contains ones, right?
Not only one,
Hmm?
not only 0, 1.
No, so your final oxy array, because you filtered out
Yeah.
all the not majority numbers, you should have only a limited number of values.
But this one after that, yeah, I place it here. So then the CO2 R.
So could you test it out? Could you put a console log CO2R right under that line?
That's exactly the same as that one.
Yeah, so just console log either one of those so we can see what it would be. Oh,
This is it.
but within your loop, maybe.
Yeah, that's the final one.
Yeah, now we can see the different loop values. Okay, so yeah, so it's just getting smaller. It's just filtering your array.
So at the initial time, your CO2 array contains all the past elements of the initial array, right? It's not filtered. It has almost all the values. 5, you have 5 there.
Well, it starts out with 5, and then it tests that position, because you're taking the CO2 array, you're filtering for each one. For each one, if the character equals a character you're looking for, which is a CO2 remove, which is either 1 or 0, then it returns that string. And then so that string is acting as a filter. So the first time through, we're only filtering on the first position to make sure it equals the same as the majority or the minority. And then we're going to the second position, and then 2 filters are doing the same thing. It's either filtering on the majority or the minority, depending on whether it's the if on 52 or the if on 60. And third, so it's basically what I said before was wrong. It's not like you're not filtering out all the numbers. You're filtering out the combinations.
Right. I just filter, yeah, all the combination. At first, it's all the combination, and then one by one, I start to remove. I mean, not one by one. It could be more than one, because you can see here there is 3 at once. Get away. According
because
to
the first position.
one, yeah,
Is that the first position? No, that was because of the second.
Third, maybe?
Second position. The second position doesn't have zeros, basically.
No.
Because it looks like the first position, maybe you already filtered out all the zeros on the first position.
right. After
Yeah.
that, one.
And then all the ones.
No, I think that's the fourth position. All the ones, the last three has ones on the first. Oh. Which position is that? Third, it's not the third, and it's probably not the second one too.
Remember, the for loop is going through each columnar position starting from the left side. So I think the first one is already filtered in all the zeros. So the first position has to have a 0.
0 after that, it's a 1.
Yeah, it started with 12 elements, and 5 of those elements started with the 0.
Well, this one is a sample one, so it's got 5.
Right.
Yeah.
5 columns. Oh, but you're saying there's 12 lines. Is that
Yeah,
what
the sample input had 12 lines to start with, but after you filtered it, there were only 5 lines that started with the 0.
right?
So that's what we're seeing there in his console.
Right, and then it goes through a second time on the second column. It does all the determining what's the majority, what's the minority, and then uses that to determine what it's going to filter on. And so you've got 2 filters going on at the same time. You've got one oxygen array, which is filtering on the majority, I guess majority or the minority. I think you have yours reversed. Because I think the oxygen is, you have it as a minority, whereas the CO2 you have as a majority.
Oh yeah.
I think he's right. We're
Yeah,
counting CO2 right now, and CO2 is a minority.
Oh, that's true. That's true. Okay, so you're counting zeros. If zeros are the majority, then you're making it a zero. So
Yeah.
no, you're right. I take that back. So zero, but so the zeros are the majority. You're counting them as zeros. And the second one, if zeros are the minority, then you're counting it as a oxygen counter is less than. Well, if it's the minority, then you make it zero.
Yeah.
If it's the majority, then you make it one. Okay, so that establishes what should be opposite, right? In terms of your final string as to what's majority and minority in each one. And then you're gonna go through each one of those arrays first in the first position. But it looks like you don't have to, on that for loop, you don't have to figure out that entire array of majority and minorities. You only have to find that column. Because in your for loop, you're actually going to go through, all of them. Oh no, I take that back. Because you're going to go through the first column, you're going to go through all the lines, and you're only going to get the first column. If it's a zero, then the counter plus plus. And then if everything is done, that's when you do that. If you, okay, when everything is done, you do that. That keeps throwing me off because it's in that for loop.
And then after, yeah.
Okay, so you have that if.
Just put a 0 or 1 in these guys, and then after that we just filter it. If it's 0 at the first position at here, then we return it at 0 or 1 according to the one we need to remove.
So CO2 remove is just a character. It's either 1 or 0. Right?
Exactly.
Yeah.
CO2 remove and oxy remove, or just a character, which I put back, explain.
Yeah. Yeah, but it'll get set anyways, right? It gets set regardless. And then you filter based on that one character that we just picked up as majority and minority, depending on which array that we at. And if it is, then that value is a good value. And then we filtered out all what started out as the entire list of, let's say 12 in our sample, you're starting to filter those out, winnowing out the ones that don't match in that for loop, every space, so you follow the directions pretty much exactly.
That's why when they make a story like that, I get lost quickly. Yeah, that's it's funny because for me it was really clear when I did it. It's like, okay, fine, but try to explain it a few days later. It's like, wow.
If we've already lost.
Even though I put the comment, I'm still confused. Like, wait, what did I write?
More comments.
Definitely, I think I'm gonna comment every line.
I need to start doing that too.
I'm gonna comment it with like verbally. All right.
Next JavaScript.
Sure, I'll go. Let me share my screen. Can you see me?
Yep.
Yeah.
All right, here we go. My part 2. Yeah, again, not proud, but it worked. All right, let's go.
Hey.
For this one, I was actually hoping that my rotation function would be reusable, but alas, it was not. I had to redo the way that I formatted my input for this one. So.
Yeah, because you need the entire input.
Yeah, I can't just, I needed to keep it in columns instead of make it into rows.
You could have done the counting first and then do the processing. Then you could have reused your old one, I think.
Maybe. For me, it was easier to just completely redo the way that I processed my information at the beginning into a format that fit this question better.
Right.
So it's not very reusable, but it's very focused, but it worked. So for this one, I'm just creating one array of strings. So each row is its own string. I'm not splitting each string into multiple strings anymore.
Right.
Each row is a new string. And now the only global variables I need then are my OGR and my CSR for oxygen generator rating and CO2 scrubber rating. And now I started this one a little bit, I started to try to break it down into pieces so I could comprehend it a little bit better and test my code a little bit before moving on to try to get the final answer. So I wanted first to just get the oxygen generator rating. I wanted to just make sure that I can get that, and then I can reuse that code as much as possible to get the other rating, just change a few values. So in order to do this, I used recursion. So I created a little function here where I'm going to accept a and an index value. So now I'm going to get the length of that of the first item in that array, because that's going to be the same length of every item in that array, because I'm going to just filter elements out of the original array. So pretty much just like what the question asked too. I'm just filtering out the elements that don't match the criteria. So I'm going to, just like before in my part one, I'm going to keep a total number. So a count of the sum of all the values in that column, or in that, so in that index value in each row. So at the beginning, I'm going to be looking at the first character, the first number in each row, whether it's 0 or a 1. I'm going to sum up all of those. And then let's see what I did here. Yeah, so I'm summing up the value of that number in the first column. And then if that number is less than if the sum is less than the total length of the array over 2, I'm going to add a 0 to my OGR, or else I'm going to add a 1. Do we follow?
Yeah.
I could have also changed this. I could have done greater than, and then I just swap these to a 1 and a 0. It would be the same thing. All right, and now I'm going to filter my array based on that information. So I'm creating a new array that gets the filtered data from that array. And I'm going to filter it. What am I doing here? Yeah, so I'm getting the first element.
You're checking if the initial, the 3 or 4 characters are same.
Yeah. Yeah, that's why I have my index value here. So I have to keep track of my index to make sure that many characters.
The ones who are remain should have all the same characters in the initial indexes.
That's right. All right, and now I have to do one more check here. So if I could actually change this. So if my filtered array pretty much has a length of 1, then I could return that value as my oxygen generator rating. And then if I don't only have 1 value left, I'm going to run my function again with my filtered array, and I'm going to increment my index value. Do we follow?
Yeah.
So every time my starting array is just going to get smaller and smaller until it narrows down on just 1 value.
Right.
And because it was easy enough to just copy and paste this whole function for my CSR, that's what I did. I just had to change my conditional here. This one I kept my same one where if the sum is less than the average, then I'm gonna add 1 to my CSR. And if it's not, I'm gonna add 0.
Wow.
But other than that, and then I'm gonna do recursion with my get CSR function as well. Pretty much the exact same as for my oxygen generator rating. I'm just searching for the lower number and not the higher number.
Right.
And that was it. Now I just have to get those 2 values, and I'm gonna multiply them together.
Cool.
We'll multiply the decimal values together. That's why I % with my with 2 right here.
Right.
Binary.
It's a binary.
All right. Not the cleanest, most beautiful code, but it worked.
Yeah, it's interesting that you went for a recursion instead of looping. In fact, I'm pretty sure that after it goes through, maybe the Lexer, maybe just before going to assembly, the optimizer will probably unroll because you have tail recursion. It'll probably just unroll into a standard loop.
For me, this was a lot cleaner to look at, a lot cleaner to read. And if I wanted, I could probably combine both of these functions and just add like a third argument for whether it's OGR or CSR.
Right, and then do an if.
And then I could just handle that in my if statement here. And but then I'd also need to call my function 2 times here using both arguments.
You can also send a callback.
That too. Yeah, so there's a lot of different ways we can do this one. Let's see how Farouk did it.
I think I passed more arguments and used the same function to calculate ratings.
Okay.
I think if you pass one more argument to your function, then you could use exactly the same.
Yeah.
Yeah, I think for me though, this saved me time because like I said, my initial thought was I wanted to make sure one of my values was correct first, and then I could get the other value easily. So actually, instead of just modifying my original function, it was easy enough and easier for me to read too by just copying that function and changing the necessary values.
Right.
So I know it's not beautiful, but for me, this was faster and easier to read. But yeah, if I wanted to improve it later and reduce the code, then I would go back and add in a third argument like that.
Okay.
But just to get the answer before you guys did, this was the best way for me.
And you made it. You did it before you got it.
All right.
Always the competitors.
All right, now I will start. Okay. Is my screen visible?
Yep.
I will bring this to lower. Okay. So I think mine was quite similar to what Scott had is, so I basically have my input here, which is all this mapped into a string, mapped into a list separated by commas as a separate strings. So I'm passing my input to this part 2. And part 2 is having them separating the same input into 2 different variables, because those 2 variables will call the same function with different arguments to have the different output. So my oxygen rating is calculated by this helper function. Actually, both of them are calculated by this one. I have the initial input, which is same as this one. And I have this 1 and 0s, which is different for both. So my calculate function rating has these counters here, and it will loop through each element. I think the looping is similar to part 1, as the number of times, how many characters it has. So first, if it has 5 characters, it will loop 5 times the length, like that. So let's say my sample input here has 5 characters. So it will loop through 5 times the length of the input. If the index 1 equals 0, we count the zeros, basically 0 and 1s. And if the one count is, if the 1s are more than 0s, we have this filter here, filter input. So for the first one, oxygen rating, it's 1. So we are filtering based on this argument. If it equals 1, we are keeping elements with the 1 in that index. But if this filter 1 equals to 0, we are keeping elements with 0 in that index every time. So we count it once, we count it twice. So we have these comparators are same. The only difference is these arguments in this helper function. And while I'm looping through this list, if at some point the length of the list will reach 0, there is no point at looping through, so I will return the input. Otherwise, it keeps doing the same track multiple times. Yeah, this filter is basically similar to filter in JavaScript, I think. So we pass the callback function here and the list that we want to run this callback function on. So my part2 function will call the same function for oxygen rating, we'll call the same function for scrubber rating, and convert them to decimal with base 2 and returns their multiplication.
All right, yeah, it looks exactly like mine in JavaScript if I had combined both of my functions into one.
Yes, I think logic is
Yeah.
Does
So any questions?
Python pass lists by reference or by value? In other words, could you have passed just the input and have Python pass by value? I don't remember if Python passes by value or by reference. That's why I'm not asking as like a quiz. I'm just wondering.
So I think at this point here, it's passing by value.
So if it's passing by value, you could have just passed input, because a copy of it would have been passed when it got into the function.
And then this one here. Yeah, that means, yeah.
I mean, it's worth trying. I don't remember off the top of my head because it's sometimes hard to keep my languages straight. But
Yeah, it's the right answer.
okay.
So actually, before I refactored it, I had it as two different functions. So the variable was initialized at that point, I think, yeah.
Okay.
Is it?
So it's just a remnant.
Yeah.
Okay, looks good.
Good. Any suggestions?
I think, in passing filter 1, filter 2, you could probably put that into one, just made it one parameter and just made the other one opposite because it's only ones or zeros.
Oh,
You could have saved yourself one argument, but it's not that big of a deal. Whatever.
yeah.
Just made that a ternary. Yeah. Both of them would have been ternaries at that point.
Like this, right?
Well, it would have been filter 1. You don't have to actually need the, you don't actually do need the one filter 1. Oh yeah, you do need the comparison. So filter 1, yeah, equals 1 question mark. But you might need a parenthesis maybe to make sure it gets precedence over the first double equal sign.
Here. I said filter 1 close to 1, right? But
No,
I think ternary was same.
yeah, I think that's correct. And then the other one also needs the ternary, right? But the opposite ternary.
But I have this showing me the. I think I forgot to close it, right? No.
What is it? What's the error?
Says the parenthesis was not closed. Here.
Where's the other open one?
There's only one.
Yeah, so
There's
we have 2 then.
I'll be right back.
That's odd. Maybe you have another. No, you don't have any other parentheses anywhere.
Oh, maybe we can. Just here. Temp, for example. Here.
But question mark, is it if instead of question mark?
Maybe Python might not have a ternary too. It may just
They
be
do,
if.
they do, but
they do?
it's if, I think,
If
instead of
else?
question mark.
Oh, okay. So equals 1 if
Yeah.
it's not if.
Ah,
It's not
yeah,
if filter 1 equals 1.
in here, right?
No. Instead of the question mark where you got the error, I think it was if.
Here.
Filter equal 0, 0. No. Remove filter 1 equal.
Yeah.
0 or 1. I don't know what was the value you wanted to put. Then after the 1, it's if. And no, and then if, and then instead of dot, the colon is else.
Instead of column, what?
Else.
Yes.
Else.
Yeah.
Looks weird.
And yeah, it's,
I think, no, let's go back down. In order for that to make sense, it would have to be, see, report y equals 1 if, and then filter 1 equals 0, else 1. In order for that line to make sense. So report y equals 1.
Okay.
Or quote 1, because it's a, did you want it as a string or did you want it as a number?
String.
If, and then after that, if, and then whatever filter 1 equals, in this case, 0, else 0, or else 1, yeah. So that's the only way it would make sense. And then you do the same thing with the one on top. So report y equals 0 if the filter 1 equals 1 else 0.
Right.
And you got list index out of range.
I think 53 and 57 are not right now because, like, for example, on 53, report y is always going to be 0, isn't it?
Filter 1, it should be 0 if filter 1 equals to 1.
Well, on 52, you have if one count is greater than the 0 count. So what do you want that to be?
so I think it's
What was the question?
the value is before the if actually. If so.
I think it will be always 1 here.
So
What was right? Yeah.
this time it
It's always that one's always going to be 0, and the other one's always going to be 1. So you want this one. You want it to be.
I think, yeah, I will.
Definition comes after the is.
Yeah.
Yeah.
Yeah,
It reads better. It reads.
it worked how it was.
It might be.
So what happened?
It might be time consuming.
Oh, so you're going back?
Yeah.
Okay.
How about?
I think it was just a problem with the if else that we had right there. I think we just need.
I think I can use a ternary operator here. We just had a tiny syntax issue. I'm sure about that. Ternary operator should be fine with passing only one argument. Yeah, I will put it somewhere there.
Anyways, we all got the answer for number 3. We're gonna see the rusty one for part 2.
All right. See, where is mine there? Okay, so most things are the same. I think I may have changed my input. Let me see. Yeah, so I changed my input. So I started out as a vector of strings or a list of strings. I changed that to be a list of characters instead. So I split up each string into a character. So now I have a vector of characters. I found that easier because I needed to do process one character at a time. So I just pre-processed the entire thing into a vector of characters. that make sense? It just means that my line list, instead of like, let's say there's 12 in the sample, I got 12 lines, right? And so each line is normally just a string, 10, 11, 10. But I took that string 10, and I turned that into another list of characters. So character 1, character 1, character 0, character 1. That's what it's changed. Because I just found that in terms of the way I was doing it, it's a little easier to process. Other than that, I think I pretty much copied that I had on part 1 to see which one has a majority, and I called that function process. And so everything between 22 and 36 was borrowed from the first part. There's some language specific things that I had done, like a vector, since I didn't really need, I was able to what Russ called borrowing instead of sending by value. But anyways, the only other thing that changes with the original one is that my gammas array, I have one extra test if it's a majority, and it equals what's called E, which meant that it's equal, that 1s and 0s are equal. That was the only test that I do something special. But other than that, if X is greater than the majority, then it's a 1. Because remember, I'm counting ones. That's my whole like logic is I'm just counting ones to determine majority or minority. Anyways, other than that, I have this entire large function here that gets rating, and I get the rating of either the O2 or the CO2, and then I pass in that input, which is, remember, the vector of characters, which is just like string, except each string was split up into characters. And then let's see what I do. And then while the rating vector, which is the input vector cloned, which now that I think about it, I probably just could have sent a reference or a borrow in Rust terms. But anyways, as long as there are lines to process, vector rating length is greater than 1, because I'm going to be using the rating vector as a filter. So as I find stuff, I'm going to start pulling things out. So as long as there's more stuff to filter, I'm going to keep running through the loop as long as there's stuff to filter, right? As long as lines haven't been removed, right? Because remember, we stop when there's 1 left.
Yeah.
And then so let's see what I'm going to do. I'm going to be taking that line, however many there are, and I'm going to be calling process. And process, remember, was before get the majority. And so it's going to go through and it's going to calculate all the majorities and the minorities. Basically, it's going to count all the ones. If the ones are the most common, it's going to have a 1. If the 0 is the most common, it's going to have a 0. If they're both the same, it's going to come back with an E. That's the only thing that's really different from the last one, right? And then so if it's a CO2 thing, then I'm going to flip the bits. If E, then I'm going to just leave it at E. But if it's a 1, I'm going to do 0, and otherwise if 1 equals 0, otherwise I'm going to leave it as a 1 and then collect. Let's see. So that should flip all the 1s to 0s and 0s to 1s. If it's a CO2. And then after that, I get the iterator and then I do a filter. If the 2 lines are dissimilar, then if it's CO2 rating, then I make sure that that's a 1. If it's not a CO2 but an O2 rating, then I make sure it's a 1 if it's equal. Otherwise, if it's not an equal line, then I just return whatever came in. Right, either 1 is greater or 0 is greater. So at the end of it, I should have a rating of whichever one. I should have the binary string of whichever one was acceptable for each rating thing. And I do that every time. So that filter should filter out as long as the number is the number it's supposed to be for that particular index, then you're cool. And that should be it. The only weird thing is that there is an index, so it's a while loop, but because of the index, it's going to do it by column. Every column, it's going to process each column one at a time.
So yeah, you implemented it. So.
And so it's a little bit more roundabout, I think, because basically I'll end up processing all the columns to see which ones are major, which ones are minor. But basically, it shows how many ones there are. So I have immediate access to which ones are major and minor, and which ones are equal. And then depending on the line coming back, as I process, it filters and it process and I filter and then it process and I filter and then process and filter, depending on each column as to what I need. And it should only process the leftovers because every time it's only filtering and it can process the filtered values and then filtering and processing filtered values and doing that on a column by column basis through the while loop.
I find it interesting that we're only on day 3 already, and already we have all of our code is completely different.
Already we are not proud of our code.
Yeah, already we have such different code, but also there's a lot of similarities between
Sure.
some of our codes too.
Actually, it's similar.
Yeah.
Pretty much, actually.
Yeah. I mean, the only thing that I've done that's maybe different from your guys is that I introduced the E.
Yeah.
So my counting, I don't do anything special. As soon as I find an equality, I just mark it as an E and I process it later.
Yeah.
Whereas a lot of you guys have processed that equality right away.
Mhm. Right.
At least help me cram it all into one function. All right. Other than that, it's the same, you know, collecting string radius, unwrap, all that noise that seems to happen in Rust.
So it looks like a mix of many languages, like let, print, ln.
Yeah, I wonder if that optional chaining thing in JavaScript came from or conceptualized from this Rust thing on question mark thing too. Maybe.
I'm sure it came from some language.
Right?
Oh, you're talking about this output. Where do you see option chaining? Or are you talking just about functions?
Yeah. I think in Rust too, you have this question mark too, since that first day, right?
But oh yes, I see what you're talking about. Yeah, the question mark when you're using options, because there's the possibility that nothing might come back.
Yeah.
Right. It could be a none or a sum. Maybe.
Right. It might have been.
But that's a different version. Well, maybe. Because that one, it actually comes back with an object called option, and you have to process or at least provide a handler, otherwise it has to panic. So it's a little bit more extreme in Rust, right? Where it'll just crash. But you can prevent the crash by providing some alternate route for the no value. But the optional chaining in JavaScript just returns an undefined, right?
Yeah.
Yeah. But
and then you have to do something around.
Yeah, it also avoids just crashes in some cases.
That's true.
Undefined, but
but it doesn't force you to deal with the undefined. Whereas in Rust, it's like if you want to do it, you have to actually call unwrap and say, "Yep, you know, whatever." I realize it's going to crash. It's fine. Otherwise, you have to handle that none possibility, that none option. So yeah, I guess it's somewhat similar. It just says that Rust like forces you to do something about it, whereas JavaScript are like, yeah, I just add it and just keep going. If you never add an exception handler, it's like, yeah, whatever.
It's a really recent language. Just check that.
Yeah.
2010, the first appearance.
So like 11 years old. So 2010. So what's that? Like JavaScript was 93, 94. Is that right? 96,
I
93.
think around the time.
My bet's 94.
95.
95, okay. So 6 years before Rust.
6 years before.
You said Rust was 2010?
Yeah. 95 the first time.
Oh, sorry, it's 5 years.
You mean
So I was thinking
15 years?
So 15 years? 2010. Oh my gosh. Okay. My math. Yes. Very bad at math. That's why I have a computer. But yeah, 15.
Like 6 years, 10 years ago.
Yeah. Hmm. Okay.
Right.
But so cool.
Yeah. The 8 today.
Two-dimensional data structures so far, not too bad. We're doing iterations, no skipping, no special behaviors depending on what we find other than counting. So not too bad so far.
Yeah, there hasn't been anything too tricky. I'm sure we'll get there.
All right.
Bingo. Next time we have the bingo, the squid.
Yeah.
I think it's the next day. I think it's day 4, the bingo.
And I think we all have our code up on either GitLab or GitHub, right? So people can also follow our code or see how we're doing, even in advance of some of these videos. But
I have mine on GitHub. Should we share our links?
yeah, I don't know if I'm logged into mine actually. Oh, I am. So I'm logged into. Oh no, I am logged into my own. So I am Iron Llama.
All right.
Not fairy llama. I
Not
run
Furry
them.
Llama. I am the Iron Llama.
Okay.
You can find my past admin code as well as my current admin code. I think there might be some years missing, but I don't know if that's because I didn't do it or because I didn't upload it. So I have to check on that. But you'll find my code there. Anybody else wants to share their links?
I will share.
Okay. And I think I'll probably add it to the description in the videos as well to make it easier for people.
So my username is AoC2021
Okay.
in English maybe. So if you go on repositories, should advent of code. I have only for 2021 since it's my first year.
Okay.
Yeah.
Cool.
I share here's the link, AoC2021 advent of code.
Okay.
Okay.
Do you guys want to share yours too for the JavaScript side?
Yeah, Alexi, you first. I'll share mine next.
It's mine. So just need to.
Oh,
Picture.
Yeah.
Oh, looking good.
And then
James Bond.
Yeah.
Advent of Code 2021.
Okay.
So just this one.
Gotcha. Okay.
Sharing.
All right, I'll share mine. You can find me on GitHub here, Scott Henshaw 86. And all of my code's in my Advent of Code 2021 folder. I haven't pushed in a while though. I got things going on my Windows machine and on my MacBook, so I need to catch up.
Okay.
He doesn't want us to copy.
Well, partly that too.
Well, at least you got up to the video. That's it's really well.
Yeah, at least I think I do.
Follow.
Yeah, I got my day 3 in here. All
Cool.
right.
All right. Well,
See you on Friday.
yeah, good luck. We'll see you guys again on Friday. We'll meet again and we'll talk about Thursday and Friday's questions and we will go over answers for day 4.
All right. Good luck.
Hey guys.
Good luck. Have fun.
Yep. Catch you guys later.
See ya.